So let's take a look at writing a series in summation notation. It says write each series using summation notation. So we're going to start off by just putting a sigma, and that means the sum of. Now I'm going to go ahead and put in my domain. Now remember, this is the range of this. This is a function, okay? This series is their functions. I'm going to put in the domain. The domain is the natural number set. Now, you could actually start with a different, we call this, in this particular case, we're going to call it the index, but you could start with something different. You can't start with a negative, though, and you usually don't start with a 0 because typically you're going to use the proper domain, which is a natural number set. So let's go ahead and instead of n on this series, I'm going to use I for an index, just because you're going to see that, and I just want you to get comfortable with seeing an I, just like we see an n. They're the same thing. So we're going to start with 1, and we see that we're going to go to 5. In other words, I is going to be 5 when we're finished. It's not that we do 5 of them that's going to be 5. Okay? So, well, in this case it is that we're going to do 5 of them. But the next thing that we're going to do is we're going to find out what is if there's a common difference, if there's some kind of plus or minus that is consistent, and we do see that it's plus 6. So when I see that it's a constant common difference, or it is a common difference, then what I'm going to do is put that number in front of my letter that I've chosen, the I or the N, whatever it happens to be. And then I'm going to put a plus or minus and a box with a question mark. And here's what my next question is. If I plug in a 1, how do I get it to be an 8? If I plug in a 2 for I, how do I get it to be a 14? So in other words, if I plug in a 1 right here, that's 6 times 1 is 6. What do I need to add or subtract so that it will actually spit out an 8? Well, it looks like I need to put a plus 2 there. So that's what my thought is. If I just put in a plus 2, then that would give me my 8. Well, the next question then is, would that work for one down the line? For instance, if I put in a 4, with this new rule that I've come up with, let's put in a 4, would this new rule would it give me a 26? Well, let's see, 6 times 4 is 24, plus 2, indeed. So I know, since I've checked it, I know that this is indeed my rule, the plus 2. So let's go ahead and write the whole sigma notation right here. I'm going to start with 1 and go to 5. I'm going to add these terms, 6i plus 2. Those are the individual terms as long as I put in I as 1, 2, 3, 4, and 5. I'm going to add those terms together, and that's what a sigma notation means. We're going to tell somebody else to go add them together once you get all the terms. Okay? So let's take a look at one more. Now this one looks a little bit scary because it's fractions, but don't be afraid of these kind, especially when you see a constant number at the top or the bottom. Those are easy, easy, easy. So what I'm going to start off with is I'm going to go ahead and place the number of terms. Well, I look at this right here and I see that, well, it's not going to have a particular number of terms. In other words, the ending is going to be infinity on this one, so I'm going to put an infinity there. Okay, so this is still the first one, second one, third one, fourth one, fifth one. So I'm going to let my index, start with 1. Now, I'm going to deal with the numerator separately than the denominator. Okay, so I'm going to go ahead and give this one a denominator. So it's real easy to see that I'm just going to have 7 on top of the fraction. Here's the problem. I have an alternating sign. Negative, positive, negative, positive. On and on and on. So actually I'm going to move that 7 over a little bit. Whenever I want an alternating sign, I'm going to put in a -1 in parentheses, right? The negative has to be included in the parentheses. I'm going to put in a -1, and I'm going to give it a power. I need to scoot that over one more time. I need to give it a power that would produce this. For instance, what would I want the power to be? Would I want it to be just I, so that when I put in a 1, that would be raised to the first power, and it would give me a negative. Okay? Would putting in a 2 right here, let's see if it'll work, would that cause that -1 to be a positive? Yes, it would. Would putting in a 3, an I of 3, cause it to be a negative again? Yes. So the -1 to the I is going to give me negative, positive, etc., etc. If it had started off with positive and then it went to negative, I'd probably want to take it to the power of I plus 1, right? Because then it would be squared and it would end up being a positive initial term. All right, so let's look at the denominator and see how we can go from a 1 to a 1, a 2 to a 4. So this is what we're trying to do. We're trying to put in, by the way, this is the I. This is the I's. These are the I's. So I'm going to put in an I of 1. I want that to be a 1. Well, looks like we're just going to put I squared would work, to the first power would work. So let's just do this, I to the first power. So now let's put in a 2, see if that'll work. Put in a 2 and we want it to be a 4. Oops. If I put in a 2 for I in the second term, then it won't give me a 4. I'd have to square it. Well, would that still work for my, would that still work for my first denominator? Well, put in a 1 and squared would still be 1. If I put in a 3 and I square it, would that give me the 9? Yes, it would. So what I'm going to do is I'm going to check this one. I'm going to use 5 as my I. I is 5, and I'm going to see if it's going to work. So I have -1 to the 5th power times 7 over, now 5 is the I, and I'm going to square it. So let's see what we get. -1 to the 5th power, that has to be done first. So it's going to be still a negative, so I'm going to have -7 over 25. Let's see if that's what, that's exactly what we were supposed to get. So it says that this is indeed my summation notation. Okie doke. Hope that was helpful. Thanks for watching.